So to recap yesterday, we have a plane whose engine has failed.
Pretty good.
Thanks. In elementary school, I liked drawing military vehicles. And the altitude is 3,600 feet. The plane engine has failed. Fizzle. And we're falling. But we can still glide. We've got a runway. Three miles away.
We can do it.
We can do it. We got this.
And how many feet a mile?
5280. 1 mile equals 5,280 feet. We need to know how much to cock the nose down so that we make it to the runway. In other words, we need to find the angle of depression. Remember, angle of depression is always with regards to the horizontal. So this is the angle. That's what we're looking for. Okay. So, which trig function do you think I'll need?
Sine.
Brett says sine. Here tangent. So if you're going to use something like sine, then it's going to involve the hypotenuse. And I don't think that we're going to use that here, although you could find the hypotenuse by using Pythagorean theorem. But to save that step, I'm just going to use tangent. Now I need an angle. I might as well use this unknown. Now here's the challenging part. It's what over what?
2,600 over 15,840.
Very good. This angle here is also the angle of depression because it's alternate interior with this one, and we're assuming that the ground is parallel with this horizontal line. Tangent is opposite over adjacent. 3,600 over 3 times 5,280. If you just put in 3, I tried that before, you get an answer of about 90 degrees, which is straight down. I don't think you want to do that. So that's an error. It's over 3 times 5,280. 12.8 degrees. Okay, that's how much we'll have to tilt the nose down to make it to the runway by just gliding. Any questions on 5? So, kudos if you were able to do that. Yes, question?
I was saying, like, probably if you were really fast, I think you'd be able to calculate it before using like cheap computers.
This is one of the reasons that we've made computers. Because they don't make mathematical errors, and they're much faster than us. I asked my friend who's a pilot, how much trigonometry do you use? He said, not a lot, but he still needs to know it because sometimes the instruments fail. Not a position you want to be in, obviously, but it's a fail-safe, I guess, yeah. If you're programming a calculator, how many problems do you have to do before it knows every problem? Excellent question. I don't have an answer to that question. My gut is telling me that there is no answer to that question because there's an infinite amount of problems. I think the answer is no. There's no way because you can't know every single problem. I mean, that doesn't mean that all is lost and you can't do anything. You can teach it to solve certain types of problems. And through artificial intelligence, you could have it maybe learn, like human beings can learn. But that doesn't mean that you can just teach it something and then let it go and it's just going to be able to solve everything after that point. Yes. But it's a very interesting thing to think about. Again, any questions on Fiverr? Okay. 6. This time we are working with angle of elevation. Any skiers? One skier. Okay. I hope that you have a good ski season this year. Nice. Okay, we have one other skier, I assume. That you're going? You're a skier? Here we go. Chairlift. Vertical rise of 2,600 feet. Vertical rise. The length of the ride is 1.8 miles. That is a long chairlift ride. How long does that take? Jeez.
You don't think a little more slowly.
This is one heck of a mountain. We are interested in the average angle of elevation of the lift. So angle of elevation is up from the horizontal. And it's an average. So your lift could not go in a straight line, and it probably doesn't. You know, it probably goes up, down, straight, up, etc. But we are interested in the average. Okay. Brett, what trig function? I think sine is a good choice now because we have the hypotenuse and we have the opposite. Okay, so the angle of elevation is going to be the inverse sine of
2,600 over 9,504.
Very good. So 1.8 times 5280, 9,504 feet.
Will that be given to us on the quiz?
Yeah, I'll tell you how many feet are in a mile. $15.9. So not very steep. If it was a steeper angle of elevation, would the lift ride be more or less? If it was a steeper angle of elevation, it would be less. Yep. But may not be as pleasant. Any questions on 6? Good. We're on a bagel. Number 7, a ship travels 93 kilometers on a bearing of 29 degrees. Sweet. Bearing. I'm going to stop there and start drawing. When I see a bearing number that has no direction attached to it, I know that it is using the convention of 0 degrees being north and the angle being measured clockwise from there. So my recommendation to you is to draw a north ray, because it involves that, and then go 29 degrees clockwise from that point. And that's your direction of travel. So you're going northeast. And we have traveled 93 kilometers. So that is the length of that side. Next, after that 93 kilometers, we change direction. We go on a heading of 119. So again, a north arrow, and 119 degrees from that. You're learning to be navigators, which will come in handy if you ever want to fly a plane, sail a ship. There was that 14-year-old girl who sailed around the world. 14-year-old Dutch girl who sailed around the world. There's a documentary about her. It's called Maiden Trip. I watched it on Netflix. Very interesting. And she had to know how to do this stuff. Work with maps, charts, things like that. Yes. She was alone, in quotes. She was alone on her boat. But she had people following her.
Did she ever utilize them, or was she kind of just not a right through there?
I don't think she ever ran into an emergency. There was a reporter that was following, and she would make stops in ports to resupply and to talk with people. Like her parents met her, I think, in the Caribbean or something like this. Anyway, still really impressive in my opinion to be a 14-year-old on a boat alone, doing everything on the boat that's necessary, and it's a sailboat. Yeah.
Did she go through the Panama Canal?
Yeah, she went through the Panama Canal. Yeah. Anyway, find the distance from the starting point, which is here, and the end point, which is here. No problem.
Isn't that just 93 plus?
I'm a trig master. So, Amber has asked, is it simply 93 plus 113? That is one way to interpret it, but I know that that's not the way that they are meaning it.
Oh.
Okay? They mean the straight line distance. I think Pythagorean theorem is nice, but Gabe, what do we need to know about this triangle?
Oh, that's a right triangle?
That it's a right triangle. Yep. So, our question is this a right angle? If it's not, then Pythagorean theorem is going to give us an erroneous result.
We could draw alternate.
Ooh, I like it. Somebody said alternate interior or alternate something. Your north lines are parallel. If this is 29, what's this? Also 29. Alternate interior. This is a straight line. 180 degrees. Remove the 119. Which is 180 minus 120 plus 1, 61.
Yeah.
61 and 29. Equals 90. Okay. So I repeat, if you didn't know, or if this was not a right triangle, the Pythagorean theorem would give you an erroneous result, because that only works for right triangles. So therefore, and soon in this course you will study non-right triangles.
What is 3 dots mean?
Therefore.
Okay.
93 squared plus 113 squared equals x squared. So it's going to be the square root of 93 squared plus 113 squared. 146 kilometers. That's the straight line distance from start to finish. So many applications of right triangles. Any questions on 7? All right. And the last one. Radio direction finders are set up at points A and B, 8.68 miles apart on an east-west line. I encourage you to be slow, deliberate. Stop after every pertinent phrase or after every sentence. Process it. A and B, 8.68 miles apart, east-west line. Okay. A, B, 8.68 miles in between them. It's a horizontal line because it's an east-west line. Next, from A, it is found that the bearing of a signal from a transmitter is north 54.3 degrees east. So what's key here is from A. That's your reference. We have a bearing, north 54.3 degrees east. They're telling you it's north, so draw your north ray, and that it's 54.3 degrees east from there. So 54.3 degrees clockwise. There's some signal. This is called triangulation or trilateralization, or trilateral something. Okay. Next, while from B, it is north 35.7 degrees west. Notice a triangle will be formed. North 35.7. So, like when you hear on TV shows or in movies, triangulate their position, this is essentially what they're doing. And that's how GPS works. Okay, we want to find out the distance of the transmitter. This is the transmitter up at the top. From B. So this is our X. Okay, I've got one side of a triangle. I either need at least one other side. I think I'm going to fail in that effort. Or an angle. Let's try the angle approach. If this is 54.3, what's this?
90 minus.
The complement of that. Very good. 90 minus 54.3. 35.7. Okay. Do the same thing over here.
54.3.
Yep. 90 minus 35.7. No surprise, it's 54.3. And the only reason I'm allowed to do that is because A and B are on an east-west line. So there's a 90-degree angle between north-south and east-west. Add those two up. You get 90 degrees. And since angles in a triangle have to add up to 180, you have proof that your top angle is 90 degrees. That unlocks tools like the Pythagorean theorem, the trig ratio definitions. Okay, so 8.68, what side of the triangle is that? This is going to be the hypotenuse because it's opposite the 90-degree angle. So tangent, out of the question.
Cosine.
We can use cosine if you use the 54.3 degree angle, because x would be adjacent to that. Cosine of 54.3 equals x over 8.68. .06 or 7. Miles is the distance. Okay? Any questions on 8? It's common for people to ask, well, if the computers can do this for us much faster than us, and without the chance of making a mathematical error, what's the point in learning it? I think it's a valid question that should be addressed. What did you say? Yeah, I wondered that as well. And I think the answer is that if we stop teaching people how it's done, and let's say a generation goes by,
We'll be done.
you would have nobody who knew how to do it. And then if anyone had to make any changes to the computers, maybe make improvements to them, nobody would know how to do that. So we would remain stuck.
It's also like your pilot friend said, like if there's a malfunction or something, he needs to be able to do it.
Exactly. If something goes wrong, you need to fall back on the knowledge. Good.